Now in this video, I've got the PNP S8550 transistor LED circuit. On the collector side of the transistor, I've got a blue diode in series with a 500 ohm resistor. Across the collector emitter, I've got a red diode. On the base, I've got a 22 microfarad capacitor in series with a 4.6K ohm resistor. And coming off the base, on the positive side of the circuit, I've got a 1N4007 diode. Across the entire transistor, I've got 13 volts, and I've got a switch. Now, what's happening in the circuit right now? The answer is absolutely nothing. Now I'm going to close the switch. Now when I close the switch, the current begins to flow out of the base through the capacitor, therefore turning the transistor on. Now when the transistor is turned on, the collector current comes up through the emitter and through the collector and through the blue diode and through the 500 ohm resistor. So now the blue diode is on. Now when the capacitor fully charges up at about a voltage of 12.4 volts, the transistor turns off. When the transistor turns off, the red diode turns on. Now the reason that the red diode turns on is because when the transistor turns off, the volt source exclusively is now supplying the current for the red diode and the current for the blue diode. So at this time, both diodes are on. Now, why do I have this diode right here? This diode is here to drain off the capacitor when the switch is open. So now I'm going to open the switch. Now when the switch is open, the capacitor will discharge through the 4.6K ohm resistor, through the 500 ohm resistor, through the blue LED, through the red LED, and finally through the 1N4007 diode. And at this point, the blue diode is off and the red diode is off. And this brings me to the end of the video. Subscribe, like, and share. Subscribe, like, and share. Thanks for your attention.